Okay. Okay. Now today we'll go with chemical calculation nights day 4, right? So now we are in our fourth night, not fortnight, fourth night. Hare. Then the first thing today, last week we spoke about concentration. Today we have to see how to see the number of moles, initial moles, reacted moles, remaining concentration, those things now we are going to find. Now, Buddha, just imagine I am mixing two things. Now they have given a bottle like this, they have given two bottles. One bottle, they have labeled it as, okay, this is one bottle. In the label, it says 0.1 m HCl. We have another bottle. In this bottle, they say 0.2 m sodium hydroxide. Now what are they doing? This is A, this is B. They take a beaker and they put, this is A, this is B. AB. Then we'll think they put 50 centimeter cube from this. They put 50 centimeter cube from this. Right? Okay. Now finally, what would be the final concentration, final volume of this? 50, 100 centimeter cube. Now we'll give some questions related to this. Now this is, we are mixing two solutions. One is 0.1 MHCl, other one 0.2 m sodium hydroxide. Shall I do like this? HCl and sodium hydroxide are, it's not funny. Like to get something useful, I'll change the label. We'll put this as 0.1 m H2SO4. 0.1 m we'll put this as 0.2 kilo will change. Okay. 0.2 m H2SO4 kilo I'll change. This is 0.2 m sodium hydroxide. First question. I'm going to develop so many questions on this, carefully observe. Question number 1. They will ask, find the we'll put this here. Find the number of moles of H2SO4 in C. This is the first question. Okay, in C. Now what you have to do, how to find the number of moles? What is the formula, Buddha? N equals, simple N equals, simple N equals simple M or capital M can we use here? This is a thing related with what? Concentration and volume. The concentration and volume nang N equal CV. N equals EV. C equal NOV, N is equal CV. That is okay. For concentration, what should I use? So they are asking here H2SO4, no, concentration of H2SO4, 0.2. Okay, you can write the unit 0.2 mol dm minus 3. What is the volume? we have put only 50 centimeter cube. So volume I can use 50. So we have to convert to decimeters, no? So divide by 1000 and write as decimeters. So I can simplify this. 50 and 1000, we get 20 here. 0.2 divided by 20 mean we get 0.01 mole scale. I will get the answer. Okay, 0. Divide by 20. Okay, okay. No? If you have problem of division, you divide slowly. 0.2 divided by 20 and say. Find the number of moles of H2SO4 we found. We are developing a question now. Second question they will ask you. Find the number of moles in the sodium hydroxide they can ask. That's the question number 2. Right? They can ask find the number of moles. Okay, find the number of moles of sodium hydroxide they can ask. Right? Find the number of moles of sodium hydroxide in C. That is question number 2. Okay. Find the number of moles of sodium hydroxide. Here also what? Same way, same thing, 0.2. Shall we change this concentration? 0.2 will change as 0.5. We'll change the 0.2 as 0.5. That's 0.8 kilo will change. Is in 0.8. Right. Then second one will be find the number of moles of sodium hydroxide in C. There are same thing you have to use. What is the formula for that? C equal NOV. C equals N equals CV. Same thing. Here concentration we know 0.8. MOL dm minus 3. Volume is same 50 no Buddha. So volume I will put 50 over 1000 to put it decimeter. I am doing this quickly because already we know these things. These are not new things. So everyone okay no, with this? So if I simplify this, again I will get 20 here. 0.8 divided by 20 mean I will get the answer as 0.04 MOL dm moles. So this is okay. Now, third one, they will ask you a question like this. Number 3. They will ask you, find the limiting reactant and find the remaining moles of the other reactant. So this is the question. Okay, now this is only main part of today's part. So I was developing this part. Okay, right, fine. Now find the limiting reactant and find the remaining moles of the other reactant. First of all, to get this, Putha, I have to write the reaction between these two. If I write the reaction, I can write like this. Now who are acting? Sodium hydroxide and H2SO4, they are reacting together. Then you will get, when sodium and sulfate join together, I will get sodium sulfate. So I will get Na2SO4. This is sodium sulfate. And this OH and H, when they join together, I will get H2O. To balance this, here you can see there are 2 sodiums here. Therefore, I have to go and put 2 sodium here. Now check the number of atoms in left and right. 2 sodium, 1 sulfate, 2 hydrogens here. There are 2 hydrogens, 4 hydrogen, 2 oxygen. Therefore, I have to put 2 here. Then this is balanced. Okay. So first of all, you should write the balanced reaction. Normally acid-base reaction, always you get the salt and the water. Right? Salt, water. Then now, carefully observe. Then first of all, I should write the initial moles, what we put for this. Initial moles. So I can write initial moles. Initial moles. What is the initial mole I am using for sodium hydroxide? I found that, right? 0.0. How many moles I have? 0.04 moles. Sodium hydroxide I have used 0.04 moles. How many H2SO4 moles I have used? 0.01. These are the initial moles I have used. But you see the stoichiometry. Your stoichiometry is 2:1. This one. This one. So it means if you want to produce these products, okay, 2 sodium hydroxide and 1 H2SO4 should join together to produce these things. So they should join as 2:1 ratio. Okay, 2:1 ratio to produce these things. So here, who, for an example, will think we are using complete sodium, all 0.04 sodium hydroxide here. If I want to use 0.04 sodium hydroxide here, how many H2SO4 moles should be there? The ratio is 2:1. If I want to use 0.04, how many H2SO4 should be there? 0.02 should be there. But do we have 0.02 there? No, it means H2SO4 not enough here to react all the sodium hydroxide. We'll say if we are reacting 0.04 H2SO4 completely, what is the amount of sodium hydroxide I needed? 2 times of this, no? 2 times of this means 0.02. But I have sufficient sodium hydroxide. So whoever not enough, then they only we are calling as the limiting reactant. So who is not enough here? H2SO4 is not enough. So we call H2SO4 as the limiting reactant. So the answer for the limiting reactant is H2SO4. Did you understand how to check that? First of all, you check if I use this fully, how much I need. So we have that? Then okay. Then check this one also. If I use this one completely, then do I have that? Then you will see whoever not sufficient, they are limiting reactant. Limiting means they only limit it. For an example, we'll think you are making sausage bun. I have told this story. You are making sausage bun. We'll think when you are making sausage bun, you need, or we'll think it's a double layer sausage bun. So you use 1 bunnies and we'll think you put 2 sausages in 1 bunnies. These bunnies, these sausages, these sausage bun. We'll think you got 10 sausages. You got 10 sausages. 10 sausages. And you got 4 bunnies. 4 bunnies. We'll think you have 10 bunnies there. 10 sausages and 10 bunnies. My question is, how many sausage bun you can make in this type? Only 5. So who is the limiting factor here? Sausages. But sausages are not enough. You have only 10 sausages. To make a sausage bun, we need 2 sausages. So can you understand? This is only same thing to produce. This is the product. This is the reactant. Then this set is okay. Then Putha will write the next statement like this. Initial moles, we'll put a thing like this. H2SO4 is not sufficient. How you spell sufficient? Tell the spelling. SO how many F? H2SO4 is not sufficient. H2SO4 is not sufficient. Therefore, it is the limiting. Therefore, it is the limiting reactant. Right. Now, then I can say like this. Reacting moles. Reacting moles. Reacting moles, now who will finish completely? Whoever limiting reactant, that will be finished completely. Again, 0.01 of H2SO4 will be used. If 0.01 of H2SO4 will be used, mean how many sodium hydroxide will be used? 0.02. So I have to start with the limiting reactant. I have to start from this. So reacting moles is this much mean. Next one will write producing moles. Producing moles. So production is where? This side. This is not producing. Now here these are blank. Reacting, these are not reacting, these are producing. Okay, now you can see 0.01 of H2SO4 has reacted. So here you can see the ratio 1:1. So sodium sulfate also produced how much? 0.01. You see the just ratio. 1:1 ratio, so 0.01 reacted mean 0.01 produced. Then 0.01, this is 0.01, mean this should be how much? 0.02 are produced in water. Can understand these things? Everything clear? Great. Now, Buddha, finally I can write reacting moles, producing moles. What is missing? Remaining moles. Remaining mean finally what is in this solution KL only I have to see. Remaining moles. Now, do we have remaining sodium hydroxide here? Yes or no? Yes. Why we put 0.04 sodium hydroxide here? Now, what is the remaining sodium hydroxide? It is 0.02. How we got this? Now you can write 0.04 minus 0.02 KL I can write. Do we have remaining H2SO4? No. Do I have sodium sulfate remaining in this? Yes, in sodium sulfate produced, no, it is there in the solution. Yeah, what is in the final C solution? Sodium sulfate also there. The sodium sulfate how much are there? 0.01. Do we have water in this? Yes, 0.02. Finally, what is this C remaining solution? Remaining solution in the C is, this C is a mixture of what? C is a mixture of sodium hydroxide, sodium sulfate and water. So finally, these are the things in this. Can I understand? Okay, can I understand this final thing? Right. Okay. And they will ask. And finally they will ask. Now again, you have to understand to create this chart. I hope you can understand this and you can create it alone. Finally, I can create another one. I can ask another question. I can develop another question based on this. Right? What is it? I can tell like this. That next question. What is the next question? This is question number 3. No? Question number 4. Find. But you go home and complete this note, right? Find remaining sodium hydroxide concentration. Find the remaining sodium hydroxide concentration. Okay. Find remaining sodium hydroxide concentration mean I can write like this. What is the formula for concentration? C equals. Okay, C equals. I can write as C is equal to N divided by V. So I know the remaining moles of sodium hydroxide we found here. Sodium hydroxide 0.02 moles are available here. So if 0.02 moles are available in sodium hydroxide, I have to put 0.02 moles. This 0.02 moles are available in what is the volume? 100. No? Now C is this C concentration. Now this is in 100 centimeter cube. No, all these things. Sodium hydroxide we have 0.2 moles. Sodium sulfate we have 0.1 mole. Water we have 0.2 moles. This is the total number of moles available from each of the item. H2SO4 went away. So this is 100, so I have to convert to decimeter, so I have to divide by 1000. Then can write as decimeter cube. Then what can I do? I can change this as a multiplication, 0.02 multiply by 1000 divided by 100. Okay, this one I can write MOL dm minus 3. Then if I simplify this, finally answer will be, finally the remaining concentration of sodium hydroxide is 0.2 MOL dm minus 2. Okay, again you should be able to do these things. If you can connect these things, or easily you can do the calculation part. Right. So this part is okay. Again, we developed a final thing like this. Okay. So without going in this way, make one part. And make question I will copy paste and I will go in a different direction. I'm going to go for a different direction here, a completely new question set. Right? All right. They will ask like this. I can give a new set of question. What is the new set of question? I can ask. Directly I can ask. Find, there is a new set of question. Find the concentration. Find the concentration of C. Find the concentration of H2SO4. Find the concentration of H2SO4 in C. If I ask like this, find the concentration of H2SO4 in C, if I ask, how will you do this? What is concentration? Concentration is equal to number of moles divided by the volume. Okay? Then I have to find the number of moles you put here. No? Carefully observe. I will do two ways. I will do in two methods. One is shortest way. One is longest way. First, I will show the longest way. Properly, if you think, how will you do this? With the logics. If you do with these things with the logics, first you will find NH2SO4. NH2SO4 already you have found here. NH2SO4 you found in the previous one. That is N is equal to CV. The concentration of H2SO4 here 0.2 MOL dm minus 3. The volume of H2SO4 is, you put only 50 centimeter cube of H2SO4. So this is the number of moles you are inserting for this solution. This become how much? 1, this become 20. Already we found this in the previous one. This answer will be 0.01 mole. Now, what does it mean? You have put 0.01 mole of this. Okay, you have put 0.01 mole of this. Can you understand? If you have put 0.01 mole of that, if you have put 0.01 mole of this, so what can I do? I can find the concentration. Now concentration equals N divided by V. The same formula we are putting again and again. N is 0.01 moles. Divide by, what is the volume here, Puta? Now the new volume is 100. New volume is 100 mean the concentration of sodium hydroxide here, new volume is 100 divided by 1000. Then I will get the answer 0.01, this is in decimeters. Then multiply by 1000 will go up, 100 will come down. Then I can write this one as MOL dm minus 3. Then 0 and this one I can simplify, answer is 10. Then I will get the answer as 0.1 MOL dm minus 3. This is the concentration after mixing this. But remember, if I want to find this concentration after mixing two solutions, if I want to find the concentration, there is an easy way. What is the easy way? This is the easy way. If equal volumes are mixed, if equal volumes are mixed, equal volumes mean, you can see this also 50, this also 50, this also 50. So they are mixing equal volumes. If equal volumes are mixed, remember, there is a rule. Concentration become half. Concentration become half. If equal volumes are mixed, concentration become half. So I can write like this. Earlier concentration was 0.2 m. Earlier concentration was 0.2 m. H2SO was earlier concentration was 0.2 m. If you mix equal volumes, divide by 2, now you get the answer as 0.1 m. The steps, number of steps you are doing like this, right? And you can reduce to this. But when you are writing, write this word. If equal volumes are mixed, concentration become half. Right? So remember this part. Okay? Clear? Without finding one by one, I can find the concentration using volume ratios. I can find concentration using volume ratios. For example, we'll think, okay, we can find the concentration using volume ratios. For an example, we'll think, we are mixing two things. Okay, just imagine we are mixing two things. One is 0.1 m sodium hydroxide. They are telling like this. You are mixing 0.1 m sodium hydroxide V centimeter cube. They are mixing 0.2 m H2SO4 V centimeter cube. They are giving only this much. And they are telling, okay, they are asking new concentration of sodium hydroxide after mixing. What should you do, Buddha? Tell me. With V, you can't do in a long way. No? V and V, when you can see both are same volume. When same volume are mixed, what will happen to the final concentration? It become half of it. So directly you can write new sodium hydroxide concentration is 0. Divided by 2. 0.1 mol dm minus 3 divided by 2. Then you get the new concentration as 0.05 mol dm minus 3. These are some easy techniques to get these things. No need to go one by one. Directly you can divide by 2 and you can get it. Okay. Then there is one more thing. If you put without giving equal things, if you put different volumes, what will happen here? If you put different volumes, we'll say 0.1 m sodium hydroxide, you are putting V, right? 0.8 m H2SO4, you are using 3V. Now they are asking, okay, final concentration of H2SO4 after mixing, right? Remember, Buddha, right? Remember, there is a thing like this. Final concentration after mixing. After mixing two solutions. After mixing is equal to its its volume fraction. It is equal to its volume fraction. Again and now, if I write H2SO4's volume fraction, H2SO4 volume fraction. What is the H2SO4's volume fraction? Now after putting 3V and V, what is the total volume, Buddha? 4V. No? 3V and V totally, it is 4V. Now I am going set of series. Again, you watch this and you double check, slowly you finish this. H2S over volume fraction is how much? 3V over 4V. So H2S over volume fraction is 3V over 4V. Now V and V get cancelled here. Answer is 3 over 4. No? 3 over 4. Right? So now you can write H2S over concentration. I can write H2S over concentration like this. No? I don't know that if I put a box, that is concentration. So what is the earlier this one? That earlier concentration was 0.8. Now the new concentration will be 0.8 into 3 over 4 mol dm minus 3. Right? Mol dm minus 3. So you can write the new concentration will be 4 and 0.8. You can cut 0.2, 0.6 mol dm minus 3. You can remember, easy method, you can get these concentrations. These are some short techniques, right? These are some short techniques to get the final concentration when you mix things. You all understood this? Slowly, beautifully, you go home and complete this note, right? Slowly, now can you understand chemical calculation becoming podda advanced? Right? Chutta it becoming advanced. Therefore, nicely maintain the note.